what I wanted to start off with today was going over the various grammars that people gave me for Antler, just so you could kind of see different styles people took. I mean, most people had very different styles from each other and from me. And there's some things that you may like about something that you see. There's some things you may not like. Sometimes they're simpler. Sometimes they're more verbose. I tend to have a few more rules in my grammar, and that ends up leading to a few more methods in the parser listener. I took all identifying information out of here. You'll probably recognize your own. At least I hope I took out all the identifying. I took out all the package statements were really the place where everybody had their name. So I got rid of those. But just kind of go through these real quick here. This one chose to have separate rules for each of the border, flow, and grid. And we'll see that widget combined everything together. So there wasn't a concept in here of having containers versus components. You don't necessarily need it, but sometimes that might be helpful depending on what you're doing in your model. Cardinal widget is used in two places, so for the border and for the frame, and then each of the little sub rules for the widgets are very simple, very straightforward like that. In this one, the only terminals we have are ID, int, and white space. These rules here just kind of group some possible names together. So instead of having to say direction equals paren north, south, east, west, it gets delegated to another rule. Make sense? Questions?
Did that work? What was the center thing on this one?
The center thing? So you're right there. Now, now what's happening here is that each of these quoted things creates a unique token. When they have the same text, they use the same token for it. So it's the same as if we created a separate rule down at the bottom, center in all uppercases, colon, quote, center, quote. Okay, make some sense?
This is not mine, but when I did that caused me a problem. So
see, by the time we're done, we're going to figure out which one is John's because he's going to say that same comment for every single one.
I don't care. Positive feedback already. I think looking at each other's things is very interesting because I almost just asked after we were done last week, like, how did people approach this? Because I'm interested in.
And I'll do the same thing after the X-text one as well, so people see it. And there's a couple little things I'm going to point out. There is something in this grammar that I don't like, and a couple people did the same thing, and that's this right here, where we have dot empty. What's the problem with that? I mean, obviously those who I graded will have read the grades. They'll know what the problem is there, but anyone want to? You can't put any white space between the dot and the function name. So a better way to write that would be dot space quote empty like that. And now we have two independent tokens, one for the dot, one for the actual keyword or function name. And
You gave me some because I was having trouble today. By the way, you probably shouldn't do that. And I was like, oh, I didn't think about it, but after, the white space does make sense.
and so it just makes it less flexible for the user. And it ends up, let's see, is there possible conflict on that one? I believe it could create some, this one it wouldn't necessarily, this language, because it's the only place the dot's used, but in other languages where dots might be used in other places, you could create some conflicts between your lexical tokens at that point.
Realizing where those conflicts are.
It is painful, yeah. Trying to get a grammar to be non-ambiguous can be a challenge. There's a lot of tricks to it, but a lot of it is really just, first of all, making sure that you've factored out as much as you possibly can. So wherever there's common things, try to use common rules for it. Try to use common tokens for it, and that'll help things quite a bit. Okay, any other questions on this one? Let's take a look at the next one here. Okay, so this one, we have a lot more very explicit tokens down here. So we can see each of these, and this is perfectly valid. This one I'm not a huge fan of. I don't usually like to alternate, put a lot of alternation inside of terminals. I like to have separate tokens for each terminal. That way you can reuse the terminals. So like the word, if I had the word west used somewhere else in the grammar, this could cause a conflict because it would come up as, it would possibly be two different tokens. So instead, having it be a single token called west would allow us to still use it as a terminal if you wanted to. And some people prefer having terminals. It's perfectly valid. But at the same time, you can use it in multiple contexts. Let's see. So the rest in this one, some of it's kind of similar. You'll notice that there's a separate container and component list, and component has container as basically a subtype of it. So this is another approach you could actually write this for. It really, in this particular example, it probably didn't make that much of a difference. But if you ever had a language where in some spaces containers were the only thing you could put someplace versus a component, then this would be very, very useful. So if you had some kind of a special, you know, I don't know, build container keyword, and then after it you could put a container as opposed to a component, this would allow that and make sure that the grammar only validates it one way. And let's see, is there anything else in here that's interesting to point out?
So you would have, well, center and then northwest, east, all as Lexer tokens, and then up in the rules you would use, you know, an OR with all 5 of those.
So either one of two ways. Either have separate north, south, east, west, center tokens, and then up here say center or north or south or east or west, or instead of using explicit Lexer rules for it, just put the quoted names right up here. And then that would take care of it. Try to see if there's a conflict here that caused the issue to separate out center.
This is mine, and I already did. That's why center is its own button outside of the
That's kind of
order,
interesting.
direction, and flow direction.
Yeah, I don't see anything that would be a conflict in this.
Well, I think it's because he's using it both in flow and
No,
he's
so-
using the same Lexer token both in flow and order.
But
and frame.
only in the rule up here. When I had them, when I had center as another OR token in both order direction and flow direction.
Oh, I see. I see what happened. Because, gotcha, because it was needed for flow as well.
Find those as Lexer. What are those?
So I made those.
These are terminals or token rules.
If you had just typed that into the actual,
Yeah, then it's fine.
then it's fine. 'Cause
Right,
that's
right.
what I did. 'Cause
So-
I ran into the same problem.
The
but I
problem
said,
is, right,
just copy it.
if I did that, right, because order direction comes first, as soon as I try to use center as a flow direction,
It
it's
wouldn't
gonna
let you use it there.
interpret as an order direction.
Exactly. Now, if instead you had these split out, you would have been able to put center or left or right here, and then up here center or north or south or east or west, and that would have worked. So this is an example where the same token is used in two different contexts. So either using the literal for it in both places or using an explicit token will work for that.
I think I ended up using the literals in a lot of places because it just.
I just like it because it compresses the grammar a lot. I mean, from Antler 1 and your earlier other types of tools, you had to specify everything as separate Lexer rules. And then starting in Antler 2, he allows you to put the literals actually in line and then just generates a token. And that just made things so much easier because these, you know, especially if you're dealing with like a real language, you know, like a Java or something, the grammar can be huge. Yeah, I wrote a Java 1.5 grammar a while back. There was an article I wrote on, what the heck was it? It was about Antler, using it to parse Java, and I can't remember much more about it, but I did it for 1.5, and ooh, that was a bear. At least it wasn't C++ though, which would be a complete nightmare. Okay, so any other questions on this one? Okay, so let's take a look at the next one here. Now this one, something that I found interesting about it is the terminals are up at the top, and I had never even considered that. It's perfectly valid, but every time I've seen a grammar, I always saw the terminals at the bottom. So I'm kind of wondering, why didn't I ever consider that before? But it's like, most people don't do it. So it's actually not bad readability-wise because you can come in here and see how am I grouping my letters into words, then how am I actually going to group the words into sentences. So it's a different style. Made me think about it. Now this one here, we have a component here that's combining the text, the button, and the label, and all of the layouts there. I wasn't too keen on that. One of the main reason is that each of these attributes, like text there and comp, those, it means that in your parser listener, you have to actually do a lot of conditionals to check things. I prefer breaking those down so that you actually have separate context objects to look like. It's less checking. Now, it does result in more parser rules, though. So there's a trade-off on that. The other thing I didn't like necessarily about that is that we're really kind of combining two different levels of things. One is, this is basically the guts of one of these guys, versus these here are references to the guts to somebody else. So that's something that I like to see them either kind of an even level, or group them all together and then have a huge conditional, which wouldn't be as keen there. So let's see. So you have direction and components there. Component can be any type of component there. Let's see. Was there anything else in this one that was interesting? So yeah, this is kind of the idea of how you'd have those together there. And this could have been in line, but because it's used in, was it used in two places? Yeah, so because it's used in two places, making a separate rule for it's nice.
Did anyone figure or try to figure out how to limit you to one of each direction at most?
You can do that in Xtext. You can't do it automatically in Antler. So in Antler, what you'd have to do is say, let me get my component, look at all the directions, and make sure they're unique. In Xtext, they have, you actually can use a single ampersand between them. So if you said north, ampersand east, ampersand south, and so on, then it'll only let you pick one of each of those. That's great for things like modifiers on Java functions.
Okay, so instead of or, you would use one ampersand.
Mm-hmm.
That means
Pretty sure it was the ampersand.
valid, but only one of each in like a.
At most, yeah. At most one of each. But now depending on if you had it just like this with the ampersands, it doesn't really buy you anything because you don't have a star. It's when you have a star on there that it ends up being useful, because then it can collect just one of each and it validates that. That was a nice little thing they added into there. Okay, let's see, anything else in this one? And here's another one here. This person went for a lot less less vertical density. So the file isn't quite as long. You get more on the screen at once. There are things I like about that. I like long lines. It's like some people are like, no, 80 columns. And it's like, I can kind of get it. Basically it's the Linux heads who are like, I want to make sure I can run it on VI on an 80 column terminal. It's like, if you're running on an 80 column terminal, you have more problems to deal with. At least that's the way I look at it. Yeah, you need a bigger screen, dude.
I like the short lines because I can put a bunch of files next to each other.
That's another approach.
That all the time. I want to look at 2 or 3 things at once, and if there are 80 columns, I can fit 2 or 3 depending on how.
Monitors, that's the whole.
Yeah. Yeah. There was one guy I worked with who on his screen had 4 separate windows, and he was running Linux, 4 separate windows running Vim in each one. This guy was the fastest Vim editor I've ever seen in my life. I mean, the stuff he could do with 2 or 3 keystrokes was amazing. The thing that made me cringe was watching him try to navigate from one file to another. And he'd like pop out to a shell and then be like cd //d//dot//////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////////// I mean, it's, the people like that are like, oh, it's so much more efficient. It's like, no, I don't know why people have this hatred of IDEs. It's, they're there as a tool to just help you navigate. That's the big thing. And it's like without that, and the syntax highlighting. God, I mean, when that first started, like it was back in the early '90s, the first syntax highlighting editors. I was in heaven. If you haven't lived through a time when there weren't syntax highlighting editors, you're lucky. Okay, so let's see. So we have frame, border direction. So the direction thing is kind of similar. In this case, you'll notice that the direction and the actual component are grouped together into one rule, as opposed to a separate direction one and then a separate component, pulling those together. For X text, I find that that's actually going to probably be a little easier to deal with, because then you have a object that holds both of them. In Antler, it really didn't make that much of a difference either way. Question or? Whoops. Stupid drag. So we have different types of layouts. This rule here, they didn't have to be in they didn't have to be in parens, so you could have just had border or grid or flow there. Let's see. So grid looks flow components. So then those two are grouped into a top level thing of potential content. And let's see. So then the individual components there, validation, the evaluator, everything looks good there. For some reason that it was looking like there were double things there because I saw these comments and it just, my mind went, huh? I don't know why, but I don't really think that comment's necessary. So any other questions on this one?
How does the interaction of down a couple lines when you put the one Lexer rule inside the other one?
See, that's screwed me up.
And so you have a plus.
So like this one here?
A star.
Now, normally what you do is you mark, you would take whatever type of rule you have here. Ooh. I mean, this will work okay. It's just, normally what you do in Antler is you'd create a fragment rule, which is just a helper rule that you include from two different places. And a fragment rule is one that you can't directly include. So it's just meant as a subtype. So here really should have been a 0.9 or have a fragment digit, colon 0 to 9. And then here you could say int is a digit plus, and here just reference a digit. That'd be perfectly fine. This will work. I'm not thinking of any place here that would be, well, one thing that there's a problem here is an ID should have a plus. You don't ever want to have an empty ID.
He's got a first thing.
Oh, thank you. I didn't notice that. Okay, so that's fine. And then followed by that, and then this could be, with the star closure versus the plus closure, what this will do is this will first of all group the integers together as a group, then apply the 0 or more on top of it. So the 0 and more will only, if it's all integers after the 0 or more, we'll just say 1.
But if it was like the other way around, the inner one was a star and the outer one was a plus, would that be?
If the inner one was a star, then you could have any number of nothings.
Right. Or you get one or more of nothings, right? And so anything then matches that, right?
Yeah,
That
would be a problem.
This way is fine, but the other way around.
Yeah, if you had a plus a star closure inside of a plus closure, that could be a problem. Assuming the star closure is the entire alternative, because then you'd have an empty alternative. So that could be a problem there. But yeah, for this one will work. It's just not ideal. I'd create a fragment rule for that. Okay, so this one, I mean, compared to that last one, it looks sparse, right? Not a whole lot there. I tend to like having things, alternatives laid out like that more. I don't think this is mine, though. I'm pretty sure this isn't mine. It looks very similar to mine, though. We're starting with the frame here. I like to have the alternatives in separate lines just so it calls the alternatives out more. It just brings them to your eye a little bit better. With the exception of something like that, where it's just inside of a smaller part of an alternative. And let's see, so we got alignment and flow.
I don't remember if you mentioned it before, but continuing off one of the first things, the end and the border being separate string things seems even more important to me than the dot one because
Yes.
I don't know, having an extra space.
A space or a tab
right, or
between them.
there would be,
Yeah, it's you want to make sure that white space is always just treated as a token separator, and that's and it'll get gobbled up here. You might once in a while have a real reason why you'd have it in the middle of a rule, or middle of a token. It's very, very rare though. Usually you want to treat it completely independently as just a separator. Okay, and the expression stuff looked very, very similar across the board for everybody.
understandably so.
Yeah. It was pretty similar to the example there. Okay, so any questions on this one? And this one had the same type of split out between component and container, where component can possibly be a container. Okay, and then this one. I'm going to go ahead and say it's mine. I don't know why I have that in there. There was some reason I put that in. I can't remember what it was. I think I was trying something out. This was a version I did before I switched over to the to doing one that actually had the actions inside the grammar. Might as well show you that. Let's see, where did I put that one? Idea projects. Assignment 4. There we go. Yeah, I think I had started to do it in the other one, decided to make a different file for it. But this is a version where I did the actions inside the grammar as opposed to in the parser listener. The parser listener is really useful if you want to do something cross-language. So if you wanted to have your grammar like this is a completely language-independent grammar. I can target Java, I could target C, I could target C++. Doesn't matter. Whatever code that gets generated for this is completely independent of the grammar. And that's a big plus. And then you would just have to implement that parser listener differently for each place. This version here, when I start putting actual Java code inside the grammar, that makes it so that this is bolted down to Java, end of story. Now, if you're okay with that, part of me really likes this. I mean, everything is just very localized. You don't have to have that separate parser listener. You still are going to need some support things like create frame, show UE, pop, and pushing different types of things. Create flow, add grid, things like that. So you'll need some kind of builder that has some helper methods in there. Of course, you could put the code all the code directly in here, but then it gets really gross. But this is an alternative to actually using the parser listener. And I think I had either, did I start with this one? I think maybe I started with this one actually. And then I created this one by stripping things out, and I just missed that one strip out. So basically I had that same kind of separation of component and container going on there. When I have something that's going to take up a lot of space, especially something that feels like it should have a nested connotation to it, I like to kind of make that nesting apparent in the grammar itself. It just kind of calls it out a little bit more that, like, here's something that surrounds something else. It makes zero difference in how this is generated. It's just something that helps me in my mind keep it a little bit more straight. And let's see. I added in a line comment for some reason. Not sure why. Just while I was doing the example, I was thinking, hey, a line comment might be nice. And so threw that in there. But most of the rest of the stuff is very, very similar. You'll notice that some people had those as an alternation. You can also include them in just a character set like that. And similar for the ID, you can do that as opposed to the explicit alternation of the characters.
Could you have done that for the int too? It's like 0 dash.
Yes.
Oh, it does. You have it there.
Yeah, I could have done that down here. I'm not sure why I did it in one place and not the other. Chances are really good that I just copied part of this from some other grammar that I found online, because I usually like to cheat that way. It's like if I'm trying to whip something up pretty quickly, I'll say, hey, somebody's created an ID 1 billion times. Let me just go grab one there so I don't have to actually think my way through it. Not that it's hard to think through, but it's just one extra thing to worry about. What's that? That's I fail. Okay, so this is the other one again with the example of doing the actions inside the grammar. Any questions on this one? Now, you obviously you weren't supposed to do this for your version of the assignment, but this is just another way you could have approached the problem. One of the things that's a problem with this is unless you're really comfortable with the way Antler deals with these $ guys, this is a pain in the ass to compile. And it had been quite a while since I've written one of these, because most of my stuff is in Xtext nowadays. But when I went to write this, I'm going through, and half the time I couldn't remember, is it a dollar sign or not a dollar sign? And then the Antler compiler would bark at me, and some of the messages in there are a little obtuse. And I had to kind of go digging. I'm like, what does that mean? I'm like, ah. And I completely forgot that you have to reference the attribute inside this context object. So when I said base equals expression, base is a context object for the expression rule, which includes an attribute called E. And so when I first did this, I was saying $E equals $base. And it was saying, hey, these objects aren't the same object. It's like, well, you're right, they aren't the same object, but I just didn't realize they weren't the same object. Okay, any questions on that? Any questions on that stuff from assignment 4? So hopefully you got a decent feel for some of the things you can do with Antler and some of the potential use for it. It's a great tool. Xtext is one that I'm using a lot more often now, though. But there's a certain class of problems that these can be very, very useful for. Yes?
Did people have like very different implementations of the actual build, the parser, listener, that implementation?
Do you mean, do they not use the parser listener versus using the parser listener? Or?
I mean, I think we were supposed to use that, right? I just meant like how people did.
Oh, you mean
construction.
students here?
Yeah.
They were all very, very similar. Very similar. I didn't see a lot of difference there.
I know when I went through this, like I built my grammar and then built the parse listener, and just worked across the examples the first time.
Mhm.
And then every example I wrote, it worked just fine. But it sounds like you broke mine a few times from the grading feedback you gave me. Having strings that weren't IDs because I didn't have a string.
That actually I picked up just by looking at the grammar.
Yeah.
Uh,
So
di-
like, I don't know, they're not different parts. I don't think there was very variance in the parser listener definition, but there's definitely a lot of difference in the grammar. Because like I didn't even encounter any of the problems you were talking about, with, like the center token being reused across different types. So I don't know. Would have been
yeah, so
interesting,
the problem I was pointing out there was that for the places where you had strings for like labels and things like that, you had label and then the ID.
yeah.
And that wouldn't let you have a multi-word thing.
Oh yeah, like just totally understand.
Yeah.
That. Just like the first time.
Oh, it was
I
just
did it,
for everybody else.
It just like worked. It's like, okay.
It's neat when it can work so easily like that. I mean, and it's like sometimes that'll happen, sometimes not so much. I find that happening with Xtext a lot more, just because I use it so often now. And it's one of those things. I'll just whip up a quick grammar and then boom, I'm running. Whip up a quick code generator, boom, I have code. It's something that for a simple DSL, I can get a model generated within a half an hour, and that can really help on a new project. It's one of those things when I'm thinking, well, write it by hand versus spending half an hour, maybe an hour, to generate it, and then I get all that benefit all throughout time. It's a no-brainer for me. Unless I'm going to have one class, then it's kind of worthless at that point. Okay, so any other questions on that? Okay, so what I want to do today is talk about working our way through the design of an application. What we might use for DSLs, things like that. And for a simple application here, I wanted to use something that I wrote way back in 93-ish, I think, for my master's program here. I was taking object-oriented programming, and the final assignment was, and I quote, write an object-oriented program. Yeah, it's like, well, boy, you're giving us a lot to go with. I mean, it's the type of thing. It's like it doesn't really give you an idea of complexity. Yeah, I'm sure some people wrote something completely trivial. My office mate and I were in the class together. We decided to write a game, so we came up with this idea of a Rube Goldberg machine, and this is actually before the Incredible Machine came out. If you've ever seen the Incredible Machine games. And we were thinking after the class, it's like, hey, we should really spend some time beefing this up, and we could sell this. It's a great idea. I mean, as you'll see, the graphics that we used to start with were, well, the initial graphics were crappy, and this was done on an Amiga in C++ to start with. The Java version, what I did is I actually stole the graphics shamelessly from the Incredible Machine for some of the stuff, and other ones I found some graphics. But it's a real primitive type thing graphic-wise. It's more, the point with this was more for how things were going behind the scenes. And let me go ahead and show you what it looks like when we run it. I basically resurrected this thing when I was teaching design patterns. And isn't this pretty? Now, one thing you'll notice is that when I wrote this, I didn't want to be bothered with drag and drop, so I click. It's kind of annoying. So I'm going to go click, 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 click. And let's see, we had the tea kettle goes there, and then the pinwheel, rubber band, TV, power. Now you notice that the power went red when it got connected there. And then this one's red because he's hot. I'm going to drop the clapper over here. He's plugged in, but he's not actually clapping. Put our clapping monkey over here. Surprise, surprise. Candle and a Christmas tree. So the idea here is light a candle, get the Christmas tree lights to blink. So what's going to happen here is you light the candle, it's going to burn this rope, which is going to release this little bottle of water, dumping it into the tea kettle. It magically is not going to put the candle out, though. The heat from the candle is going to heat the tea kettle, making it steam, spinning the pinwheel, which turns the rubber band, which is connected to the knob on the TV. TVs once a long time ago used to have knobs on them as opposed to buttons. So we turn the knob on the TV to turn it on. The monkey is watching the TV, and the monkey's a big fan of Alex Trebek, who's going to show up on the TV. So the monkey's going to start clapping. The clapping is going to get picked up by the clapper, which is going to make the Christmas tree lights blink. Okay. Now, not a lot of animation in this. It's basically just going to shift between pictures. So for the monkey, there's like a couple different states where he's clapping, not clapping, that type of thing. So I'm going to do my candle, and we'll see our Christmas tree lights blink. Ooh, exciting. Okay, so I did this for design patterns class to talk about state machines and things like that. And then I decided when I started the Android class that I was going to make the students do this. And that became kind of fun. Let me find... Okay, so what I did is each student on their Android device created all the little pieces. And you could select the pieces using a spinner. The device would then, see if I can, you'll notice here that there's barcodes I put down on the ground. The barcodes just had a grid position encoded in them. So this example was to deal with graphics, reading barcodes, and doing network communication. The first time I tried this, which failed miserably, we tried using Bluetooth for the communication. And Bluetooth is a little bit more limited than we thought it would be. And it actually, the first time we sat down to do it, we realized how many devices had to be paired with how many other devices. Really, really bad idea. I mean, it was a horrible idea. And this is before NFC. So if we had NFC, we could have at least done the tapping to pair, and that would have helped a lot. But for the first class session, the whole thing just failed miserably. So we shifted over to using just normal IP to send information back and forth. I had a laptop set up as a server, which was receiving everything, keeping track of who's at what space, what events they're firing out, and who they're firing the events to, and then sending the events out. So the end result of this, you're not going to be able to hear this, unfortunately. So we have the candle, and then have the rope burning there. I had, for this initial version, we had somebody at the server hitting a button that said pulse the events out to everybody. So sometimes it takes a little bit more time. I had him do animation on the pinwheel. And hopefully the monkey works there. And so you get to hear on the video everybody cheering. So same kind of idea. I like to reuse this example over and over because it was kind of fun. And unfortunately, when I shifted the Android class to an online class, I couldn't figure out a reasonable way to have everybody do this, so I had to drop the assignment. It did make me consider for a little bit, though, creating an application like this, distributed Rube Goldberg machine, putting it on the Play Store and trying to get people all over the world to hook these things up and see if we could get like the world's longest Rube Goldberg machine, distributed Rube Goldberg machine. Never got around to it, though. But it's an idea. So, if we wanted to create this game, let me get this tablet over here. And switch over to this guy. Good. Where do you see possibilities where it would be a good idea to use a DSL? Not just shoehorning it, but for an application like this, where you have all these little pieces, how do you think each of those pieces is managing itself? Even without a DSL, we're thinking without a DSL, what do you think's going on behind the scenes in this application?
There's definitely some sort of like trigger or activation that then affects some amount of rows or columns to a direction of a certain other kind of group or Goldberg component.
Okay, so you have some kind of trigger affecting the rows and columns, and I can't remember if that's what I called it behind the scenes. I might have called it event. But the way I managed that was it was a decaying event, so that from any given spot, like for the candle, it would release heat in 4 directions at once. And every time it moved a step on the grid, it would then say if there's anybody at that grid, send him the event. And then decay myself and keep moving in the same direction until my decay runs out. So the candle would, for example, send heat at most 3 spaces up. Then like the rope would say, oh, I just received a heat event. What am I going to do about it? Okay, what else do you think's going on here?
Some sort of state machine inside for each of the particular components.
So each piece has a state machine. Yeah. What else is going on in here? So we had that trigger. We obviously are going to need some kind of a backplane for it, right? Some kind of a grid. I'll just call it the game board. What else do we have making up this? Now think about the one that's running local, not the distributed one.
Well, you got piece type.
So piece type.
You need to know what you want.
And that's going to drive what? What will that? So it'll drive potential actions. What else?
And how to show it.
So how to display it. I'm going to just say images.
Displays.
So we have actions, we have images. I'm going to say actions/events, things like that. And then obviously he has the state machine. He drives what the state machine is. Anything else in this application? Why did I stop running that?
Piece tray.
So a piece tray or a palette. Is that 2 L's or 1 L in palette? I think 1 L. 1 L, 2 T's.
Just thinking about that as I wrote it.
Yeah, I was like, which way is it? It just looks weird. It's just the way I write. My writing is just awful. So we have some kind of palette to hold the things. One more concept. We probably need some kind of timer. So in this particular example, I had every second sending out a pulse event, so that a given piece, or like the monkey, for example, when he receives a pulse event, he'll say, change my state from open to closed on each one of those pulses. So some kind of timer. One other type of concept. I mean, it's not super apparent in this example, but how about levels? What would a level be in this game?
Like I beat this and then I play a different one.
Kind of, yeah. Well, not like the user his level, but
Or like where you are in relation to the other pieces?
oh no, not like altitude type thing.
Levels like difficulty levels.
No,
Just a collection, like a new collection of pieces.
a new collection of pieces. So he's going to say which pieces,
Oh,
and maybe a goal, something like that. Now, the version of the game that I had, I didn't have any type of end game thing. It was just basically, hey, look, the Christmas tree's blinking, we won. But having some kind of goal there would be useful, right? Yes.
Are you planning on like, for which pieces you mean, like which pieces are available on the palette or which pieces are already hard placed on the game?
Yes. So, which pieces are on the palette and let's say bolted down might be another option for which ones are actually in place that you have to deal with them already being there. So, and maybe there might be some rules that part of the goal might be, do you have to use all the pieces? Maybe you use a minimum of pieces. Which pieces end up in which state. Things like that. Okay, now think about these types of design ideas, these type of requirements. Putting your DSL hat on. And normally, it's a really bad idea to approach a problem this way, because this is called golden hammering. And if you have a tool, I mean, everything I'm telling you in here is a tool. Everything I tell in the patterns class is a tool. Take those, put them in your toolbox, and lock the damn thing. Only go into that toolbox and pull something out if it makes sense. So when you're approaching the problem, think about, what would be the best way to do things? Oh, I know that I can do X, Y, and Z. Let me pick out Y. As opposed to, hey, I just learned Y today. Let me go find a place to use that. And I used to get a lot of people in the patterns class who'd say, wow, I'm so glad you taught me that. I found 16 places to use that. I'm like, no! It's like, don't go back and find places to use things. So that said, I'm going to break the rule for the moment here because we're specifically trying to see where might design patterns apply here. Or, sorry, where might DSLs apply here? They both start with Ds. Do you see any things in here where DSLs might scream at you as might be a good idea?
One thing that I see is the state machine within each piece, specifically what triggers it and what it emits.
So having some kind of a DSL to describe the state machine for a given piece. Yep.
Just a level.
So something to define a level. Anything else?
You can define the pieces and all the events they handle, and that gets into the state machine too, with the part of the DSL.
And now it could be a slightly bigger than just a state machine definition, right? Because we might also want to define what are the images inside there. Maybe some animation specs. This one, obviously, the animation is really, really primitive. It's 2-frame animation at best. Except for the pinwheel when we did it in the class. I turned the animation in Android. It's like, ooh, it's spinning. Everybody got a kick out of that. Let's see. Was there anything else in here that might make sense? The trigger definitions, maybe. So think about I just had a brain fart. I'm sorry. I was going to say, think about the events that are for each piece. Are there any common events? Or do you think that each piece is going to have its own specific types of events?
I guess my initial thought was that there was one whole set of events, and each piece would define what events he cared about.
Okay, so one approach is to define a static set of events up front, and then each piece says, based on those events, let me do things. think about this application. Does that make sense? Or does it make sense for the pieces to define the events themselves? Because we need to have a reason why, one way or the other here.
Need two different pieces to agree on an event. So if the candle would have to agree with the rope that it's going to be a heat event.
Yep. So we need the pieces have to agree with each other on specific events. That's basically their contract, right? The candle's going to send that heat event, and somebody's going to consume that heat event. There aren't going to be any type of events here that are strictly sent and consumed by a piece itself. Does that make sense? Unless we had some kind of a really interesting effect on the board with some kind of mirror where you could send the event and it gets shot back at you. But even then, I mean, you could think of that as part of your contract. You're sending out the event, it's coming into you. So let's think about those events and the triggering type of effect on them. We probably want to define those some way, right? It might make sense for a DSL there, depending on how complex the events are. It might not. I think in this example, I just used an enumeration for it, which might be just plenty enough. But if you needed something much more complex, you might want to consider that as well. So the two big ones that I wanted to look at were the level design and the state machines. So let's think about...
The level makes the most sense, right? Because then you can let anybody design a level, right? Without having to know all the ins and outs, right? They just have to know the basic. Like lots of old games, simpler games used to let you do that. You could design your own levels for stuff. I mean, I guess, I don't know, I don't play video games anymore, but I guess they still do.
Oh, you
it
poor
now.
guy. So the comment here is that levels makes a lot of sense here because you can have users contribute new levels, right? What about contributing new pieces? Why not, right? We can have, you know, this basic framework. Really, the piece is just a set of states and a set of images, right? And the set of events it can listen to. I mean, if we think about that as our common contract, now we could have, maybe somebody says, hey, you know, I have this new set of pieces that have some specific events on them. Maybe, for example, there's some Star Trek pieces that get added, and they can have like subspace communication between things, which existing pieces may not care about. So maybe we do want to have some of those event sets being pulled in. So there's kind of this tugging each way there. So possibly event sets. The only problem you get with that is if you have have new sets of events, existing pieces are going to completely ignore them unless they have that as part of their contract. Which, when you contribute a new event, maybe it doesn't make sense that the old pieces ignore those events. Like if you contributed a new event, which is a wind gust, it probably would be very reasonable for other pieces to react to that. So if you were able to contribute that and suddenly it has no effect on anything else, it's going to feel out of place.
Could you have some way of like
Extending existing ones?
tie like a version, you know, if you have, I don't know, versioning the pieces to say like, you need this piece set if you know, want to use this event, and then you re-implement all the pieces that you affect with your new events or something like that.
So yeah, you could have version sets of things and have dependencies across different sets of versions of things. Depending on how you're designing your levels. So if you had a level that says, I have all the Star Trek pieces, and then said, okay, or let's say it was a weather set, weather pieces. So it added a wind gust. Then you could say, I require a certain version of these other piece sets. And because you're designing a level saying, here are the pieces that go in this level, you can pick and choose which other pieces you want to use. Now, if somebody else is designing a level and they decide to pull things together, they have that same choice to make of which versions do I use so they're as compatible as possible. So because we're limiting ourselves on which pieces are available in which level, it really becomes kind of a non-problem if we think about versioning, right? And make sure we have dependencies between things, which is an interesting thing to think about here. And you know, I hadn't really given a whole lot of thought to most of this, actually. So this is a neat discussion for me, too. Okay, so internal or external DSLs for these?
The level should probably be external because the users are going to want to create new levels with the version of the game they have.
Okay, so the level's definitely an external, so that users can contribute those. Unless we're assuming that our users are hardcore programmers and we give them the source, right? Then they can build it. Okay, how about the pieces?
Presumably external too, if we want people to be able to make up their own pieces and make up, have levels, have their own, a collection of pieces.
So ideally that could be external as well, right? And now if we decided for some reason that we wanted to restrict the number of pieces that are available, maybe if we wanted to have some kind of a tighter interaction of the pieces with the actual framework, we might want to do that, then maybe an internal DSL might make more sense. Okay, but externalizing it, this allows people to contribute new levels. And one of the best things you can do for the longevity of a game is let people mod it. Create new levels, do things like that, challenge each other. That's something that's going to help you keep sales up over a long time that way. Okay, so we're looking at really, in this particular example, 2 external DSLs. One for individual state pieces, and we might have just a completely independent piece per file for that, describing the state machine, describing the images that are being used. And then one for the level, which references the pieces, to say which pieces are there and set up our goals. Okay. Now this one over here, the state machine, probably not too much going on in there. We'll kind of sketch something out and see how that feels. But for the most part, it's going to be a state machine, right? Not a whole lot more there. What about the level? What type of DSL things are going to be inside that level? We obviously need to refer to the other pieces, right? So we're going to have some kind of a collection of pieces, maybe saying how many of each piece are in there. How about the goal? What might we be doing to specify the goal? So it could be actions, could be functions. It's kind of similar to something we've done already, right? Kind of like a validator, right? This is basically an interpreted piece of code. So you could have rules defined in here, and you could have a little rules engine inside the base that says when all these rules are met, the game is won. And it just evaluates that either based on a certain amount of time or based on when actions or states change of the individual pieces. And then that evaluation just says I've won the game or I haven't won the game. Does that make some sense? And I think that's pretty much all we have in there. So let's just try sketching out a couple things here just to kind of get a feel for what this might look like. The which?
Your grid size.
Oh, the grid size. Assuming we're using a grid, yeah.
You can specify the size. Because harder levels
May have more pieces, more room, things like that. Some levels you may want to really limit it, so you have to, it's more like a sliding block puzzle, putting the pieces in certain spots. I mean, you'll notice in the game that I had here, well, it's not running anymore, but there were certain parts that were very densely packed where we're taking advantage of the same events for multiple pieces. Like we were actually using the same event to burn that rope as we were to heat the teapot. Okay. Any other questions or comments there? Okay, so let me put this guy aside over here. And oops, that's actually the nested guy there. Let me first of all show you what I had from a couple different approaches that I took on this when I was doing this for the design patterns class. Here might be an interesting one. Here's a definition of a Christmas tree. Any idea what's going on here? Kind of looks like a state machine, doesn't it? I'm taking advantage of enumerations in Java and some of the more interesting features in the enumerations in Java, where enumerations can have methods, and for each individual value, those methods can do different things. So what I did here was set these methods up as the events that are being fired, and set it up so that each of the events ends up changing the state to some other value. And notice in this particular example, I went with a really non-standard formatting to try to make this a little bit more readable. Some people would just absolutely want to kill me over this because, oh no, you have to have, after that curly brace has to be a new line. But sometimes you come up with an approach that's more readable just by reformatting the code and represents what you're trying to get across more readably in your code. This was an example I did for my design pattern class when we were talking about the state machines. And this is actually, it's not really a DSL. I'm just using Java enumerations, formatting it in a different way so it's a little bit more readable. It basically looks like a table. And this, I particularly like to bring this example up because some people are really adamant, every piece of code that goes in has to run through an auto formatter so it's all consistent. And I'm like, there are places like this where it can be really valuable to use a non-standard formatting. Not always, but once in a while you'll find some case where this is actually useful. So this is one approach I use to implement the state machine. Not really a DSL, because it's just a standard language construct here. But it has a little bit of a DSL flavor to it, because I'm trying to make the code look like data. Make sense? So that was one approach I took there. You really don't want to see the original approach. I don't even know if I have a copy of it anymore, but it was gross. It was like really gross. And then I cleaned it up a little bit to make it more into a table that had the data inside of it, then moved toward this. Now there was another approach that I used for this particular example here. And I used something called the State Machine Compiler, SMC. So we take a look at the Christmas tree, for example. This is the definition using SMC. Actually, it looks really similar to that last one, right? What is this? It's a DSL. Wow. And this is one, I didn't write this one. I just found it. Somebody had written it. And it generates the Gang of 4 design pattern, or Gang of 4 state pattern. Which the idea with the state pattern is that you have each state is a separate class that has these methods, electric on, water, heat, implemented. You'll notice when I did it with the other guy, this one here, basically the same thing. Each of these values is essentially a separate class with different methods inside of it. I mean, behind the scenes, it is a separate class with values behind it, but there's only ever a single instance of it. So it's essentially doing the same kind of thing. I have a problem with the Gang of 4 state pattern in general. The idea is every state is a separate class. What happens to the overall knowledge of the state machine? It's spread out like crazy. When you take a look at your code base, there's no way for you to visualize what those states are. The state machine compiler takes advantage of what the state pattern is doing structure-wise, but gives you everything in one spot. And I think one of the big advantages of a DSL, especially when you're generating multiple things, is that you can see the relationships between those things very, very clearly. And especially for something like a state machine, I mean, this really ends up showing how things work a lot more cleanly. So If I'm unlit, I get electric on, I go to lit, unlit, get water, I'm wet, unlit, get heat, I'm burning. And when he's burning, he fires heat up. So if you set something on fire, I didn't show you that, did I? Where's run as? So you can have some fun with some of these pieces. Things like that. Or if you have a, let's see if I can get this to work. This is going to be kind of awkward position-wise. Oh, it's not actually doing it. Okay, and so now the TV's wet. Oh, I put the electric outlet right next to it, so it's treated it like it was plugged in. And then it gets fried. So, oh, actually my favorite is the monkey. He turns into a little skeleton. So it's like I had a little fun with some of these pieces. So one of the really nice things about using a state machine for a game like this is that you can have those types of effects happen. Maybe they're not what you really intend for the solution. Like there's likely not going to be any level that says turn the monkey into a skeleton. But if the user puts two pieces together, maybe that's a logical effect, is that the monkey is going to get skeletonized. Okay, so it makes sense so far? So this is one type of a DSL, and it's really not a bad DSL. FSM, by the way, stands for finite state machine. Okay, questions so far? So we're going to write a little DSL. Note that this one doesn't take into account anything with images. So we probably want to be able to have some kind of image in there. So what I did in the images directories down here is I have a separate image for each state that he can be in. So directory for the type of piece, separate images for the states. So let's create a little DSL for this guy.
Convention, your convention, the
Yep.
images,
It is, what is the name for it?
convention over configuration.
Yes, convention over configuration. So instead of somebody explicitly saying, here's where it is, I just figure it out just by concatenating names together. And that can be a fine way to do things. Now, in our DSL, we're going to explicitly be pointing to images. So, the convention helps us, but it's not actually how we're deriving where those guys came from. So let's create a little xtext project here. We'll call it com.javadude.rube.state. And we're going to have two separate DSLs here. Rube state, how about that? Okay, so how's this thing going to be structured? What do you think our top level being is going to be here? Any ideas? Piece sounds good. So I'll start with a piece. And what kind of things is a piece going to have inside of it for this definition? So he's going to have his states. So we're going to have state machine. Oh, come on, fingers. Wow. I think I misspelled that every possible way. Okay, and what does a state machine have inside of it? States, surprisingly enough. And an initial state. And we probably want to have some kind of a set of keywords in front of that just so it kind of calls out what's going on there.
When we have the square brackets around it, I know it's like almost dereferencing it, but can you just explain what that
Sure. So up here where I'm saying states equals states plus, this is actually defining the states. We're declaring those states in line, and then we're grouping them into a collection that this guy owns. What we're doing here is we're not saying create a new state. We're saying reference an existing state. And so that just creates a link, and it does the automatic link resolution for us. So let's have a name on that state.
Yeah, so what does it use to refer?
So by default, and you see the name is red there, that's because he's treated specially. He's the default thing used for that thing. If I wanted to also have a separate ID, what I could do is I could come over here and say, I believe it's that way. Or is it, oh no, it's state ID like that. I'm trying to remember exactly how that looked. I thought it was like lowercase, but apparently not. I'll have to look it up, but you can, there was a way to have it specify a different thing to use.
Name is the default.
Name is the default one, yeah. Yeah, I'm not sure. I'll have to look that up. I haven't done that much. Usually I just use the names for them. So we have initial state. Let's have a state machine, kind of like that in front of there. Okay, so state has a name. What else does the state have inside of it? Transitions. Let's say that there doesn't necessarily have to be any transitions, yeah. And a transition has what inside of it? It's an event. I'm just going to use an ID for right now. This is one of those places where using that model inferer is really useful, because what we could do then is we could actually reference the enumeration there and use the enumeration values as the valid values there. What you do is you'd reference Java identifiers, and then in the validator make sure that they're a part of that enumeration. But for right now, we don't have a reference to it. Now it is possible, and I've always had grief trying to get it to work, to have a separate DSL for the events and then refer to those components from the other DSL. I usually have some trouble getting things in the right place to make that work successfully, though. So we have event ID, and what else?
State you end up in.
So target state.
The state you start in.
Well, the state we start in,
Part of the state.
he's part of the state, so he's contained there. So target equals, are we going to bracket it or not bracket it? So we'll bracket it because we're referring to an existing state. Okay. Now, right now, what is this going to look like when the user writes this? When we have a state, what's going to happen? What would the user have to type? Mm-hmm. And you could end up just having, let's say it was the lit state. You could say lit electric on, or lit electric off, powered, electric on, stay in lit. We need some keywords in here, right? It's going to be kind of hard to read otherwise. So let's say on, event, go to, like that. And then maybe up here we might want to say we're defining a state, right? Okay. Now who's using this DSL? Us and whoever else is making levels. Are the people making levels necessarily programmers? If it's a really super geeky game, like if we were doing a Robot Wars game, then it's probably programmers. Let's just follow that up for 1 second. If I were writing a Robot Wars game, what do you think would be a good way to approach the little programming language inside there? So the idea of a Robot Wars game, if you're not familiar with it, you basically are defining a tank or a little robot, and you program it to say how it's going to act in the arena. Then you put these little robots in the arena and say go. And then they scan for each other, they shoot each other, they move around all by themselves based on how you program them. So to accomplish a game like that, what do you think what are your thoughts as far as DSL, non-DSL, or what?
You could think more of an internal DSL because you're requiring some level of. You have to think in a programming mindset to do it anyway, so maybe it's fine to make them think in a specific language.
So the comment here is that internal DSL might be a good approach here because the person doing this type of task really has to think in a programming mindset to start with, right? And an internal DSL, you might be able to simplify a few things, take some of the rough edges off. But one of the most important things in a game like that is you want a Turing complete language. You're going to want something where you're going to have loops, they're going to have assignments, they're going to have variables, they're going to have functions, everything else. I mean, just you want something that you can write pretty much any program in. And doing that in a DSL, you'd have to come up with your entire new language, right? There's actually something out there called RoboCode. I don't know, has anybody heard of it? It was a robot war game written in Java, and it's basically intended to help you learn Java. And there's some people who got really scary good at it. I mean, there's some robots out there that are just crazy. A long time ago, back when I had my Apple II Plus, I played a game called Ogre on the Apple, which was based on a board game. But the idea with this Ogre game is that you could program your Ogre and then let it go and see if it could beat all the other enemy AI. And that was a lot of fun. But RoboCode in Java, I mean, if you have somebody who wants to play around kind of learning Java and try things out, it's a great way to try out different concepts for moving a little tank around and shooting and scanning for other things. And I believe it can be multi-threaded as well. I was originally thinking of, for the assignments in this class, having you guys do a RoboCode type thing. But I was really thinking, I wanted to get to something where you're going to get to an external DSL, and there isn't a lot of point to do something like that in external DSL. Doing it internally in a programming language, basically RoboCode is a library. I mean, and that's one of the things that just makes a lot of sense for this. So big difference in a game like that versus a game like this, where we're actually doing some value add here. And we're not expecting our users to necessarily be programmers. So we got to be real careful with some of our words here, right? How about state machine? I mean, a lot of programmers have no clue what that is. Maybe we have to think of some new keywords to say, stuff that can happen. How about that? We can do something like that. Stuff that can happen. And then, boom, here's our little state machine. And then maybe down here, start here. And then maybe down here, we will say, what could we call a state? What might be another better word for a state?
I don't think better is the right word.
Condition. Status. That's not too bad. We call it a status. And we could say when something happens, change status to. And one of the things that you'll find is you're starting to write DSLs for non-programmers. You tend to put a few more words in there just so it feels a little bit more conversational. It feels a little more Englishy. And I'm not saying that these are ideal keywords here, but think about this when you're thinking about a group. Your target users may not be programmers. And in this, the simpler and more friendly you can make this, the easier this is going to be to have more and more people contribute to you. Because basically what we really want them to do is create images and define some real simple specification for how this can be used in your game. And the simpler you can make that, you can have anybody in the world creating a game. creating levels for your game. Okay, so behind the scenes, we can still call this state machine, initial state, and target, and things like that. That's fine for us as programmers behind the scenes. But what we're exposing, we might want to have something else happen. Okay, so now looking at this, do we need any delimiters inside here? So like for let's instead of just saying status, let's say well, no, status is fine. Do we need any curly braces or any begins or ends in this guy? There might be a conflict with status. Let's think about that for a second. Is it possible for state to be called where status is needed there? No. So in this case, if this optionally could be state or status, that's ambiguous, right? At least based on the first token. If we did further look ahead to see what's the next word, we could say, oh, the next word is to versus an ID. I'm good.
Two could be an ID.
To kind of could be an ID. If somebody wanted him to be an ID, they'd have to put a caret in front of it, which is kind of unfortunate here.
Well, because as soon as you've made a Lexer rule for a specific token, that's out.
It cannot be used as an ID unless you escape it, and the caret escapes it. Okay. So, but yeah, looking at this, notice that each one of these rules starts with a literal token. No matter how you get into it, you always start with a literal token, and there's no way that these rules can get to a spot where you're not sure what the next thing could be when you see a word.
State machine doesn't really start. I mean, it starts with an individual state, but you only have that once.
Well, it starts with the word status.
Right.
And so as long, the word status is going to happen there. Now, if I had something following this that could possibly, like if I said status starts with status at start, how about that? Then this one's a problem, right? Because once we get to this, when we're in this state machine here, he's going to keep saying next state, next state, next state. He can't tell based on start, or based on status, am I starting another state, or am I done with the state machine? And so in a case like this, if I needed it to look like that, I'd have to have some kind of delimiters around my state machine, or bump my look ahead up.
How do you define that?
There is a way to do it, and I can't remember off the top of my head. I've got to take a look at it. Antler has a way to turn on infinite look ahead, which will basically say if two things look ambiguous, keep going until I disambiguate. And there are cases like in C++, the difference between a declaration and an expression. There's many places where you can't tell the difference until you get God knows how far down the pipe. Now this language here, right now it's ambiguous, but we'd need two characters to look ahead to disambiguate. Because once we get to that at, we know we're doing status at versus status and then an ID. Okay, and so we don't need this guy here there. Okay, what else do we need in this little language?
Sorry, and it would be look ahead by characters, not by tokens.
It's by tokens. Yeah. Now you can do look ahead in the Lexer as well. That's a separate look ahead. But typically when you think about look ahead with parsers or any parsers, yeah, right. Because usually it's like when we group words together, we're not trying to disambiguate what their meaning is at that point. Like the word center. It could be used in different contexts. Okay. What else are we missing in here? States need to have some kind of image. So down in here we'll have status. And we'll say show image. How about that? And one thing you have to be careful of, the more words we put in this, you're reducing the valid namespace for people putting in their own names. So show image, and we're going to have image equals, let's just put it as a string. And that string is something that we could actually validate in our validator to say, does that image file actually exist? Okay, so that seems like a pretty reasonable definition, I think.
Your transition, you might want to change
If you want to do some animation in between, so that's something we could do. Is we could say when the during this change, do some extra animation of it.
that could be optional.
That could be something optional. I'm going to hand wave at that for now. Interested reader time, that type of thing. Okay, so let's see. Let's come in here and build this. Just make sure it builds okay. We're not actually going to implement the whole app here. I just wanted to go through the DSLs and see how those kind of feel. Of course, I could make that be assignment 6. People seem to like game assignments, especially in the Android class. They love doing the game. Well, some people really, really hated that game, though. I had them do Bejeweled. Okay, so let's take a look and try running this and see what happens. A new file. What do we call this? Root state? Okay, so stuff that can happen. We really should give it a name, huh? Let's give the piece a name. Name equals ID.
I'm at first.
I would put that first, yeah. Or like new object name.
Peace.
Thing, piece. Name equals ID. Okay, that sounds good. Run as workflow. And this is one of those things that'll happen when you're writing these. You'll suddenly see, I forgot something. I'm going to take a break after this. And let's run him. Okay, so now we'll start up here with piece. Christmas tree. And that's actually something we could assume the piece is actually the file name. We could have done that instead. That'd be another option. So then we'll have stuff that can happen. Status power off. Show tree1.gif. When some event, let's say electric on, change status to power on. And then we'll say start here, power off. I forgot about the here. And what is not happy with these guys? Oh, okay.
I like this way versus the file name thing because theoretically you could change it to easily allow you to put all the pieces in one file or multiple pieces.
True. Yeah, you could define all your pieces in a single file, as opposed to one file per piece.
The way this reads, it looks like show image when.
Yeah, that's actually. Yeah, that's unfortunate. But that's a good thing. I mean, that's something when you're looking at this and trying to read it, try to read it as a non-programmer. Try to get out of the mindset of how you design this. But yeah, the idea of show image when, I mean, especially if somebody put the when keyword up here, which is perfectly valid, then they're going to think, ooh, yeah, maybe that's not, maybe we should say,
Has image.
we might, well, there's two different things we can do. We can either say, see, even has image might still has image when. Kind of sounds off. So we might want some kind of delimiter between there to say show image and then when stuff happens. I mean, something there to break it up. Or we could add in a, show image when started or something silly like that. We need some way of breaking it up so that we don't have that accidental read, especially since white space is not is optional here. Well, not optional, but white space is, you can put it wherever you want. So something to break that up might not be a bad idea.
Force a reference to a particular status, like the name of. So, like, could you say show image when power off, and force it to have to be power off?
Oh, so you mean here actually have it refer to the power off there? We could do that. What's that?
Refer to me in this case.
Well, what you'd do is you'd have it refer to a state, and then your validator just make sure it's the same state. That's what you'd have to do for it. But that could be a possibility there. Another option is maybe we just do that and just separate out the images from the actual states themselves. It's like I'm not necessarily that keen on that because you lose a little bit of the connection. But depending on what you've written, that might not be too bad.
That makes sense.
So,
You-
and you could have all your images together.
Define your statuses and then start here, or status show image when. Show image.
So maybe we even did something like this. So maybe that's our structure. And this is something worth playing around with. And if you can get somebody who is not a programmer to take a look at this, get one of your kids to try to read this. And, or some neighbor kid, or, the dog. I don't know. If the dog can read this, you're in great shape. Woof, 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 woof. That's the whole thing. Hodor, 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 Hodor. That is a really hard word to say multiple times in a row. I never tried that, but I weep for Hodor. Yeah, exactly. Yeah. That one, the first time I heard that one, I'm like, damn, English sucks. It's like you can do it, like 7 or 8 of them in a row? It's like, it's, the word buffalo over and over and over again. But it makes sense. It's almost like in PL1 where you can say if equals else, then else equals if, else equals then. And that could be perfectly valid PL1. I mean, technically valid, but if anybody wrote that, they're off my team. Okay, so you'll notice that we're getting some different ideas here for moving things around and massaging it. We could come up with something that looked like this as our ending DSL. And maybe that actually makes sense. Maybe that helps. Yes?
Do you ever start with, like, writing this part and then go back into the DSL?
Sometimes. If it's a DSL that I think is going to be a little more complex, if it's something super trivial like just a real basic state machine, then I'll just crank that out without thinking about it. And then sometimes I'll have to go back and forth maybe once or twice. Something a little more complex like this, it may have made more sense to actually try writing it first and then say, I like that. And we might have picked up that issue with the when, being, potentially not ambiguous in the grammar, but being ambiguous meaning-wise to the person who's reading it. So, starting to get something here. I actually kind of like that. It's not bad. Okay. We might want to put the show images after. I mean, it just kind of depends on which way you're thinking about it. Maybe I like to think about defining those statuses first, then saying what I want to do with them. 601, half dozen of another type thing. Okay. Should we try to fix that up real fast here so we have something that matches? So we have, yes.
Just in general with DSLs, like, are you a fan of letting people decide whether they want to have show image directly under status bar or have it at the bottom, or do you want it to be like a rigid structure?
So a question is, should we have a rigid structure for the show image being after the stuff, or let them put it before if they want to? I'd be fine with putting it before. I mean, I don't think there's any issue with that. The only time you get into potential issues is if you have something that the sequence matters, like if it's an executable language. That's the time when it really makes a difference. Let's see. The only thing with putting things in multiple places is it gets a little bit harder for the user to see if they've duplicated something accidentally. I mean, you can still validate that to make sure, but if you could have the show in multiple places like that, for me personally, writing the actual implementation here for the Christmas tree, I would want to group them as states and then images. But if somebody else is more comfortable putting all the images up top or interspersing them, now the interspersing wouldn't be hard to do. Let's go ahead and code it so we can intersperse, just so you can see how that works. It does change the structure of things just a little bit. So we're going to start off with, we have our piece, stuff that can happen. That's going to be an optional, well, we want that to be a block of everything by itself. You're not going to break that up into multiple blocks, but we could put the images before or after it. So we have stuff that can happen. Instead of thinking the state machine itself containing the images are going to be outside of that state machine now, because we can have it before or after the state machine. So I'm going to go like this. We're going to have an alternative. And let's say images plus equals image. Note that I'm not putting a star after image there. I'm going to put the star outside of that alternative. This is going to allow me to have, well, no. Yeah, actually, that's not what I want to do. I just realized I like, no. So we're going to do this and that. And this will allow us to have it before or after. If the stuff that can happen to happen multiple times, I would have done that the alternatives with the star on the closure. But this is allowing us to explicitly say images could come before or come after. And this is one of those places where you're kind of like, well, is it worth it to give them the flexibility? It doesn't really hurt anything.
Could you use that single ampersand thing here to let them like order it however they wanted, but you actually do need both things?
Well, in that case, you're saying that the images all have to appear in one group. And I think that only applies to tokens. I don't think you can do that on subrule calls. I'm not sure about that, though. Let's just see. If I said A equals A name equals ID, and let's try a B here. Can I do A amper B? Whoops. No, it doesn't look like it. Yeah, you can do it for tokens, but you can't do it for rule references. That would be really painful to try to do for rule references. I'm just behind the scenes. That would be an equality checking nightmare. So this kind of thing would work, saying you could have images before and or after. Let's put the image definition. Yeah.
What if you want to do like all one way or all the other way, instead of allowing intersperse?
Okay. Well, let me throw it to you. How do you think you do it?
Is that what we're doing?
Well, if we wanted to have all before or all after, You can't possibly. You can't allow both. How could we do that?
You could just have two alternatives, right? We have one that says images followed by the stuffing happen, and then the other alternative is stuffing happen followed by images, right?
So you'd have this,
You just have to repeat the stuffing
or
happen in order to make that its own rule.
right. So something like that. That gives you the option of saying they all have to be before or they all have to be after. Now, if we wanted to break up so that you could put those images in between states, how do you think we could do that?
I guess can you show us what you mean?
Sure. If I wanted to say here, something like that.
You just in the state machine definition, you let you say a state or an image.
Okay, so in the state machine, what I would do is I would have the alternatives between the status and the show image. So in here, I could get rid of that. And then down here, I don't think I'm going to need that. Something like that. So let's see what we have here. So we have piece, stuff that can happen, and then inside the state machine, we can have an image or a state any number of times. We're adding the images and states to the list, but only doing one at a time. So you can intermix them, or you can put them all together like that. Then for each individual state, it's status with transitions. Transition is when. I think this is what we...
You're saying show image once and then you have a list of strings afterwards.
No, actually, this is going to be a single string.
It's because
There's no star after it. So what this says here is it's the plus equals just tells xtext that that's a list. I'm going to add this thing to a list, and you can reference it multiple times to add multiple things to it.
Yeah, so it's a field of a state machine object.
Yep, it's a field of the state machine object that's being created. Okay, so
we lose the association to the specific state though.
well, we didn't actually have one anymore. Oh, we forgot to put that text in there, right? So show image when power off. That's what we needed to do. So that's actually, because we want to associate an image with a state there, we need to create a separate object for it. So we'll need to have image is going to be this guy.
Kind of like show image for state name
Yeah, let's say 4.
thing, but without separating them because I like them with each other. But
So let's say state. So image.
I was doing this.
Say
You're gonna make that a bracket state.
Yep, this will be a bracket state because we're referencing a state. So we'll say states there, images plus equals image. I think that's good now. I'm going to need to close my nested eclipse.
So is yours not like when I saved my grammar or something? Eclipse would tell me like, I can't replace that. Do you want to restart your thing? Did you like turn off that setting or something?
Well, that's if you're editing the code generator, it'll do that. With the grammar, if you end up generating the grammar, then it's going to complain to you, but it won't when you save it though. Okay, so he's good. Let's try running. That list is just growing out of control. And Eclipse application. It shouldn't keep growing like that when I pick it off the list. It didn't used to do that. I mean, if I choose run independently, then yeah, it creates a new configuration. But it really shouldn't if it has the same data. Oh, it did open. Okay. Oh, crap. What was the workspace I was using for that one? That's the reason you want to have those run configurations. And so it's one of these guys, that one there, so runtime Eclipse X text. And let's see. Oh, there we go. There's the workspace there. So let's say file system. That guy.
Just watch out, it's or never mind, clear it.
Yeah, I didn't want to clear it. There we go. And we'll just change this to say 4. And there we go. So we can put it where we want. We might want to put these all below there. And actually, I can unindent those if I prefer to have it look that way. It still treats them as part of that state machine, though, because of the way it's being grouped in the grammar. Okay, questions on that? Yep.
Is there any way you can create like indent rules
For formatting?
your user?
Yeah, there's a formatter. I don't think it's in there by default. No, they don't have one by default. But there is a set of formatting rules that you can basically say based on which tokens, what follows them, what precedes them. So it's a lot like what you might specify in the IDE for other IDEs and languages. And that'll actually also give you a preference page where you can tweak those. But it's actually pretty nice that way. And you can also do something similar for syntax highlighting. So you can change the coloring of different types of tokens and things like that. Yeah, Xtext it's a really nice tool. It takes a little bit to get used to start with. Once you're used to it, you can be cranking this stuff out in no time. And that's what I like. It's like you can use if you know you're going to have to generate 20 things that are exactly the same, and maybe you only ever have to do that once. I'd still do this to make a really quick generator. Generate those 20 things consistently, and then just throw the generator away. I mean, the consistency is really what matters for me. I'm not quite sure where the line is for me, though. It's somewhere 5 to 10. Once I get over that, then I'm like, okay, yeah, I'll whip one of these up. Okay, so questions on that? Let's go ahead and take a break. Let's say 6:30 we'll start back up again. I can't imagine if somebody tried to have decimal indexes into arrays. It's like, what the hell does that mean?
No, it's something else. I don't know who it was. But
Okay, so any questions on this before we move on? I'm not going to go through the other example. I just wanted to go through an example here of kind of thinking through the design on it and seeing a potential implementation. And hopefully that was helpful and useful and motivating, because it's little things like this. You can do some really cool stuff with this to help your users provide input, especially if you're trying to target non-programmers. Then you really have to think about it and get other input from people if you can. Okay, so what I wanted to do next was go back and do a simple state machine. And do something neat with it. And hopefully I'll be able to make this work. What did I... Seriously? I thought I closed the inner one. It may have just crashed Eclipse. I don't. So let's create a new DSL. com.javadude state1. Okay, and so we'll just make a really simple state machine here. I'm going to go ahead and use curly braces in here. You know I don't need to. Why am I going to bother? We've already been through this. We don't need to. So we'll say transitions. And we'll say on event. I'm just going to use IDs for events. I'll tell you why in a minute. Well, in a few minutes. Go to target equals state. Okay, hopefully you can help program this in your sleep by now, right? I've only gone over that example how many times now? But that's a real simple little state machine there. So let's generate him. And I'm going to do something a little extra with this. When I generated this, this gives me this model directory down here that has an eCore file inside of it. This is a definition of the model objects that are generated using EMF. EMF is a framework in Eclipse called the Eclipse Modeling Framework. And this allows you to define a meta model for your data. So here I'm defining the concept of a state machine, which has inside of him a list of states. And a state has a name and a list of transitions. Transition has an event and a target. Okay, so that's metadata. We can use this to generate all sorts of different types of code. In Xtext, it generates a bunch of model objects for us, which are EMF objects. It also creates this thing called a gen model. This is something that helps us define how we want to generate our code. And we'll see inside here that he has information. If we take a look at the properties for each one of these, it tells a little bit about how we're going to generate the code for editors and for the actual code that's generated for each of these properties. So we'll see the different types of categories and things, filters, different types, the body for the getters, things like that. You can adjust the code here. What I'm going to use this for is to generate a really simple editor for state machines. So instead of using a textual DSL, we're going to use a graphical DSL. And the initial graphical DSL here is going to be a little GUI that lets us enter stuff. It's not going to be pretty to start with, but we can use it as a starting point to kind of discuss where we're going to go with graphical DSLs. So, and I'm kind of leaning towards some kind of graphical DSL for you guys to work with, but I'm not sure which one yet. Yeah.
So, is an example of a graphical DSL like a program like Mindstorms, or what's that?
Yeah. So the Lego block language for the Mindstorm programming.
I know there are other things called that that are more recent, but I don't remember.
Yeah, there's actually what was the Android one that they did with that? Was it MIT Blocks App Inventor? This one here, oh, that's just a slideshow. That sounded like that was it. How do we get there? Create apps. There we go. Never take survey. Never. So there's a little GUI builder here. Let's see if I can. I played around with this for about 10 minutes once. Media drawings, sensors, extension, Lego Mindstorms. Well, shoot. Blocks. There we go. That's what I was looking for. So yeah, this type of thing here. This is one type of a. Wow, this is just what the. This is one type of a graphical DSL, but this is a graphical DSL for a programming language. It's really intended to look like a programming language. But the idea here is you have these little pieces that you can kind of plug in. So this call tinydb to get a value. I have some tag I want to look up that's basically a variable name. And then what I want to actually use as a default value. If it's not there, I can plug something else in. And you can pick up different types of blocks for doing math. So here's a divide. Oh, that's gross. So I can say 0 divided by 0. Maybe change that to 42. So you can kind of build up some kind of programming using these blocks. I am not a fan of this one because I think it's a lot more work to create a program than just typing it. It helps guide you through a little bit more, but I think if you have an IDE that gives some really good content assist, that can be a good assist as well. But this is one kind of a graphical DSL. There's a really common graphical DSL that people use a lot. Anyone have an idea? What's that? I couldn't hear you. UML. UML is a very common type of DSL. You're using graphical DSL. You're using graphics to describe your model, and then it can generate code behind the scenes. What else? What might be another DSL, a graphical DSL that people use pretty frequently? Oh, who? Simulink. What is Simulink?
It's like in MATLAB you create a block diagram instead of
Okay, so Simulink creating a block diagram. Yeah. There's also like a VHDL editor where you're designing a circuit by dropping circuit components, things like that. Another common one that you guys may have bumped into. Something similar to a couple assignments we've had to do in here.
Oh, like NetBeans, where you can drop in graphics into the model builder.
So a GUI builder. Yeah. So NetBeans will do it. You have them in Eclipse. You have them in Android Studio, where you can design your user interface by dragging graphical pieces. So a lot of times when people think about a graphical DSL, one category in that is what we call WYSIWYG. What you see is what you get. Think about Microsoft Word. Kind of is a graphical DSL. It's basically you are dropping down, typing in things that you want to have appear a certain way. It's a lot nicer than writing the XML that happens behind the scenes, right? So some kind of graphical representation on top of things to hopefully make your job easier to do. I mean, think of what you had to do before Microsoft Word, before word processors, using something like LaTeX or Bookmaster at IBM, which looks kind of like HTML. You had a typesetting language, and you would write in stuff with some characters around it, kind of like HTML, and then have that generate whatever you're trying to do. I mean, it was gross. Over time, we came up with word processors, which can actually generate things a lot nicer for you.
Modern, like Word documents, Microsoft Word documents are like an XML type thing.
Yep, they call it OOXML, I believe it is. I think it's OOXML. Yep, and it's a standard because no, it's a standard. I mean, it's a non-Microsoft standard. which the whole open office thing drives me completely nuts. You know, people think, oh yeah, it's just as good. It's like, no, it's not. It's not even close. But they were basically complaining like, oh, Microsoft has this proprietary standard. It's like, if they opened up the standard, then other people could use it, which I think may have been a decent solution. But instead, they came up with a common standard. I think actually, if they had opened up the standard, the open office people wouldn't have adopted it simply because Microsoft defined it. I think that's how it would have gone. So we had to come up with this standards body coming up with a common way, and then Microsoft exports to it. They can export and import to it, and it's just ridiculous. I mean, it's like, you know, if we were worried that Microsoft was going to go poof, and then I'd never be able to edit my documents again, that's one thing. I don't think there's really a chance of that happening, as much as some people might want it. Anyway, so what we're going to do in here is try to create a little graphical DSL to start editing this thing. So inside here, let's take a look at this node here. He says that is that the one I'm thinking of? Yeah, file extensions are state 1. I just wanted to make sure I had that set right. This is going to, when I generate an editor here, it's going to generate editors for anything that is .state1 on the end. So I'm going to come to the top here and say, I can say generate model code. It's already generated because Xtext took care of that for me. I'm going to generate edit code, which is a set of editor objects. These are non-graphical editor objects that say how to interact, to set and get stuff. And then I'm going to generate editor code, which is the GUI that goes around this. Now that I've got that, you'll see that it generated a couple extra plugins here, .edit and .editor. I'm going to go ahead and run these now. I gorked something when I was doing that configuration.
Which one are you running now?
It's actually, it'll run, first of all the plugins that are in your outer Eclipse by default, and then all the plugins that are in your workspace. If you want to, yeah, if you want to, you can trim it down though. So you can go to Run Configurations, and then, yep, and then over here, if you say Plugins, right now it's all Workspace and Enabled Target plugins. I can change that to just the stuff that's selected below. And what you can do here is pick some plugins and then say Add Required Plugins, and it'll do a transitive closure of everything that's necessary. And then that, depending on what you're trying to run, if you're running a very pared down copy of Eclipse, that you're just using it as a runtime client for your application, that can start up a lot faster and it can be a much, much smaller footprint. Not going to save those changes. Okay, so we'll put him away. And let's create a what type of project do I want to create for this one? Oh, that's for the model. New project. Where was he? That's not him. I'm blanking on what I did earlier today to this. Oh, EMF project. I think that's what I wanted. Oh no. Let's see if this will work. I had this going earlier today. So inside here, I'm going to try to create a new there we go. So we'll see that it created this model creation wizard, state 1 DSL for me automatically, which is a little wizard to create an instance of that model. I'm going to call him my.state1. Isn't that exciting? And now I get to define which model object I want to have be the root of this model. So I'm going to say I want a state machine at the top level. Oh, that's going to be a problem. So this is why I wanted to look at the file extension, because the Xtext editor usurps that file extension. So I can either rename it, or I can do an open with and change which kind of thing I want to look at. So right now it's using the State 1 DSL editor. I can go to the State 1 DSL model editor, and now it's going to list the resource at the top and everything that's underneath it. Now we don't have any other types of objects in there right now, so I'm going to say, actually, what is going on? Why is that not? Where'd the object go? I think it might have gotten blanked out. What I was doing when I played this before is I was just renaming the extension. But let me try that one more time. I don't want to open it in that editor. Okay, I'm going to rename that extension. That'll make life easier here. This isn't what I want you guys to do. It's just a step on the way to something else. So I'm going to come back out to the outer eclipse. Let me actually close him for a moment. And I'm going to come back in. Hello. And what I want to do before I do anything else is get rid of those two projects that were generated, because I want to regenerate them after I fix this. So let's see, State 1. Instead of State 1, I'm going to call it State 1A. How about that?
That's just for the model generation thing, not for the Xtext.
Well, what this is going to do is this is going to say that the file that I'm editing, that's going to be an eCore model, has that file extension. The Xtext one is a textual representation, and there are some ways to sync them up. I'm trying to find out more about those. The documentation online has been a little sketchy so far, but I want to try to get it so that you can edit the DSL and then see the other stuff edit, go vice versa. Haven't had much luck with that yet.
Almost like when you have editors that'll like give you the GUI editor in one tab and the text editor in the other one. You just like
Exactly. So you might see a text representation of the GUI. Maybe it's an XML and then a preview of it next to it. Or you can drag and drop things and it changes the text. Okay, so I'm going to generate the edit code, generate the editor code. Let me try running this sucker again. And hopefully it won't freak out this time. Okay, so what did I call it? State 1 example, thank you. I'm going to get rid of that guy. He's going away. And let's say new other State 1 DSL model, my state A1, state machine, finish. There we go. That's what I wanted it to do. Okay, so now we have, it's kind of microscopic up there, isn't it? What is that?
Can you zoom in or not in the model view?
No, not there. I might be able to, let's say general appearance, colors and fonts. I don't know which text that's going to be. It's not going to be this guy. I will have to dig through this and figure out what text that is so I can bump it up. But I will try to tell you what that says there. So it has a platform URI saying what my resource set is. And underneath that it says state machine. Now for the state machine here, notice at the bottom here I have this property sheet that automatically pulls in properties. The state machine doesn't have any properties. I can, on the state machine, right click and say new child state, and the state has a property name. So I'm going to call this one power off. Let's create another one. New child state, power on. And then let's do one more. We're going to call it lit, for when the Christmas tree is lit. Now for each of these states, I'm going to say new child transition, and on E off, actually he's off, we'll say E on, the target is going to be, and I get to pick from a list here, power on, and then this guy here, new transition, E off, it's going to go to power off, and then this guy here, new child transition, E off, is going to go to power off. Let's say this guy says flip switch is going to go to state lit, and new child flip switch is going to go to power on. So that should define our little state machine there. Not the best way to define a state machine, but it's a little bit of a step in the right direction here, where we're trying to get something that people can pick and choose pieces to assign. But it's really not an ideal representation in any means, right? Okay, so if, what was the next thing we do here? La, 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 la. That's not him. It wasn't that. Here's the one. I'm going to create a modeling project using a toolkit called Sirius. And we're going to call this state1 dot UI. Let's see if I can get this to actually do what I want it to do. So inside here, I need to first of all set up my dependencies. So I'm going to take this project and why am I not seeing? Huh. This is not working like it worked for me before. State one example. Okay, there we go. So what I've just done is I added in a dependency on my state machine model definition. So see we have power off, power on, and lit inside there. And I'm going to come up with a graphical representation for this guy. For the model, is that it? So I'm going to say how I want to look at this model. It's called a viewpoint. And nothing in there. Well, shoot. That is not it. Let's try new representation over here. Huh. Well, this is not going very well, is it? So what I may have to do here is just show you the example that I actually got working, which is almost the same anyway. Let me try doing that. Maybe I had the wrong kind of project. That might have been what it is. Maybe it's a viewpoint specification project that I wanted. I think that was it. I think that was the problem. Okay, this is the one. That looks better. So he is in state 1 design. Yeah, this is where I want to be. And I need to add a dependency on, oh, why is it having trouble with these? I think there's something screwed up in the runtime configuration I've got here, because it was giving that error going in. Let's try that. Yeah, that is a, I think that's a problem. Okay, that didn't give an error, so this might be okay. This is one of those ones I wish I had taken some notes while I was actually trying out the example before. Okay, that looks better. See, now it doesn't have errors listed on these guys. So what I'm going to do is this state design thing is an Eclipse plugin. And inside there, I'm going to add a dependency to the plugin that defines the DSL. So I know the structure of that DSL. So I'm going to say add, look for state 1. We're going to pick that state 1 plugin. I'm going to save him, and now I have dependency. Woo, exciting. Okay, good. So now for this viewpoint that exists here, I'm going to say new representation diagram description. And that is not it. This looks completely different than what I was working with earlier today. Oh, no, okay, we're good. We're good. So we're defining a diagram with a default layer. And inside there, I'm going to say, give me a new element, which is going to be a node. And my domain class down here, I'm going to hit Control Space. And I should be able to choose state machine. There we go. Let's actually go state, because I want the things that are going to appear in the diagram to be states. Okay, and then for that node, I'm going to give him a new style. I can make him some kind of like an ellipse or a square or a diamond. I'm going to go ahead and say square. Let's.
The square is a rectangle.
Yeah, it should be a rectangle. So let's make him be orange. Why not? You want chocolate? Okay, I'll make it chocolate. Why not? We'll have him be chocolate. Probably not going to be able to read anything. Probably not going to be able to read anything on there, but we'll try it out there. So we got a state, and we're going to represent that using a little chocolate rectangle there. That would be a really good idea.
Isn't there a vanilla chocolate? I thought I saw vanilla or something like that.
Was there vanilla? Do you see it?
I thought I saw
Oh, I don't see it. It's light chocolate on top of dark chocolate. So we're going to have square chocolate there. For the label on this guy, I'm going to use the name feature of that that state. I could pick different features. So I have inside here the name. I could go to the transitions and do something with it to display that. I'm just going to display the name on there. And let's not have a little icon on there. I'm going to save this guy. And let's see, how do I get to the... Where did I have the example of this guy? Just trying to figure out how the hell I opened it up before. Some things are just so intuitive. Why is nothing appearing there? This isn't buggy at all. So what I'm going to do is I'm just going to pop over to the one that was working. Hopefully it still works. Okay, so that's the same thing. So how did I get to the...
Is it not like a run as thing?
Oh, I had to create this representation. That was it. So let's try down here. State 1. New. Oh, it's got that. So how did that have it and this one didn't? There we go. Okay. This is why it's useful to have the web page open with the step-by-step instructions. Okay, so I'm setting up this representation file. So this is going to be a how I want to represent things on the screen. And in here, I'm going to create some diagrams. So I have this state machine defined in that resource. For the diagram descriptions, I'm going to create a new diagram. This is really helpful. Oh, the viewpoint is disabled. That's not helping. Yeah. Okay. Forget that. I'm going to go back to the one that seemed to be working. So over here, I was able to add new state diagrams. Let me come back over here again. So that's model 1 for my DSL 2. That was this guy, I believe. Yeah, so I had a whole bunch of stuff inside here. So I changed that to gray when I was playing around with this before. We'll go with chocolate and white. Save it. Oh, this is gross. What the hell happened? It looks like something else.
Yeah, I was gonna say the caramel, but that's not chocolate. Yeah, that's.
There was a light chocolate and a dark chocolate, I think.
So what's white?
Okay, so let's see what we got here. Okay, now let's make those bigger. So in this guy, that square representation. That's a little better. Okay, so now we got our state showing up. That wasn't at all difficult to do. And I don't like those little icons. I'm going to get rid of those icons on there. Oh, because the color isn't really chocolate. There. How is that? Is that better? Okay. So this is the representation for each of those states. It's like milk chocolate with way too much milk.
It's like you have dark chocolate and chocolate.
Okay, so we can define a little tool palette. If we look over here, here's a little tool palette that's created with some things where we can create states and we can create transitions. And I did those by defining a source edge creation variable. This edge creation template has a variable for the source edge, a variable for the target edge, and then when we actually use that tool, it's going to make the transition object be the context we're working on. And then we're going to set his, isn't this easy to do? His state. Oh, this is something I was trying to do with the dialog, but that wasn't working. He's going to set his state to be whatever the target is that he was dragged into. So let's, in the other one here, the node creation, I'm going to create an instance of a state and set his name. And the name is going to be to however many items there are when we create a new one. So I'm going to create a state, boom, bang, there he is, and it didn't set the name. Oh well. Something was funky in there. State 1. And then this one is state 2. And now I can create a transition, boom, boom, and we can say E on. And then we can create another transition, boom, boom, E off.
Why aren't the existing ones represented between the existing states? That's probably a stupid question.
I did something silly. So I have, here's the transition, he's solid, center. What is he going from? So he says the type of class is transition. I'm going to map, the source end is going to be a state node, the target end is going to be a state node. The source is going to be the container of that transition, so that should be okay. The target is the state of that transition, so that should be okay too. Oh, I didn't have any transitions defined. I deleted them. So I just got these states. So if I came in here and said, give me a transition, and we'll say this is going to be, so this is from power off, I'll go E on, is going to go to power on. Select the proper, what the hell?
Create a new state. That's weird.
Oh, because I hit plus instead of dot, dot, dot. There we go. And so now if I go over to the diagram, boom, there he is. So between this graphical editor and the EMF editors, it's keeping the two in sync. And we can see back over here in the EMF editor, these new states had those new transitions that I added.
They're all based on the same, whatever, like eCore file or something like that that defines the model.
Right. So it's like we have that eCore defines the metadata for them, and then the actual state 1 DSL A, B, X, whatever the heck I named it, that one actually has the data. And so they're both editing that same data. There is a way to get it so that it'll sync so that you can use the textual representation that we're using in Xtext. I've got to figure out how to do that. Hopefully it'll be nice, and hopefully I'll learn a little bit more about this damn editor. But what they're starting to do here is trying to make it quote-unquote easy to generate a graphical editor. I mean, it may have seemed like a pain in the ass what I was going through there, but if you've ever tried writing one of these editors by hand, it's not pleasant. There's a lot of crap going on behind the scenes. So them doing this little editor was serious to create this. Once I figure out where everything is, it's probably not going to be too bad to create a nice little DSL, a nice little state machine editor. But this type of representation would be a lot more natural for a state machine to be able to visualize it. Well, maybe use circles instead of squares, but that type of thing. Question?
It's like exportable outside of a plugin.
Is it exportable outside of a plugin? This actually has to run as a plugin, but you can create what's called a rich client in Eclipse. And a rich client is basically a thinned down version of Eclipse that just has the plugins you care about. So it doesn't have all the extra IDE stuff. And depending on what you want to do with it, you can style it differently, change the way the tabs look and everything. Trying to think if there's what's one that I was thinking about for uTorrent. So this guy here, uTorrent, he's actually a rich client. It's done using Eclipse. So if you look at it, it does look like Eclipse. But you don't have to have it look that much like Eclipse. You can do a lot of branding and things on it. Right. Well, SWT, one of the nice things about it is it does what Swing should have done to start with. With AWT and Swing, AWT basically they're all native components behind the scenes. And to do that, they went with a subset of all the components available everywhere. So the only things that are in AWT are components that are available natively on all platforms. With Swing, they went completely the opposite direction. Everything in Swing is drawn. They don't use any native components other than the canvas you're drawing on. SWT takes the middle ground, saying if it's native, use it. If it's not native, create it. And that's really what Swing should have done. And SWT is pretty cool behind the scenes. They use design patterns really nicely.
So this is reminding me a lot of those like model-based engineering tools, and there's one of LabVIEW is not coming. I've never used that, but I used one in my last job, and now I can't remember the name of it, which is bad. But no, although that's the what
That's the idea.
IBM
Mhm.
one, yeah. What's that called? I don't know, but whatever. I mean, that sort of thinking often was thinking starting with this and then going to the code generation and stuff. And
Mhm.
as with this, frequently found that more complicated to
Oh,
as a
yeah.
creation tool than actually just typing it.
So there's trade-offs. If the graphical representation is more natural and you don't have to constantly go to the property sheet every 20 seconds, then the graphic one I think wins. In most cases, like when I use something like, hello, why can't I get to my, there we go. Let's just open up Android Studio. The big problem that I have with most GUI builders and most graphical representations is that you're constantly having to jump back and forth between the representation and a property sheet, and it really doesn't work that well. Visual Age for Java used to have a really nice GUI builder. You could do a lot just off the right-click menu and a lot by just dragging lines between things. But let's see if I have something that's interesting to look at here. Well, I'll just create a new. So in Android, your GUIs, you define them using XML. And they have this GUI builder where you can drag and drop things. And for some parts of the GUI definition, it's really nice. So I can say over here, throw down a text view, throw down another text view, constrain it to the top, constrain it to the side, constrain him to the bottom of that guy, and to the side of that guy. But once you start getting to a lot of these other constraints, you're constantly having to click here and then go here and mess with a bunch of stuff. It's much faster for me to just go over here and say, oh yeah, I want to change the margin to 16, as opposed to figuring out where it is in the GUI and doing it there. But the constraint setup for these guys here, I think is a little bit easier in the GUI builder because you can actually kind of see where things are going and how you're aligning them. Or if I wanted this guy to get centered, I can kind of throw it like that. And then if I want this guy to expand to fill, come on. I can do something kind of like that, and then he'll expand it. And then behind the scenes, he does the appropriate things with setting the width and the height. And if you have an explicit width and height, then it locks it to a size. Or if you set it to wrap content, it locks it to a certain size. So he's adjusting that for me. Other than just the general positioning and the general sizing, I much prefer to go to the XML. It's much faster.
Yes, like with the swing GUI builders, my problem with it was as soon as if you wanted to do any customization beyond what was easy to do with the GUI builder, it looked like how I would write it, and it was, they use all these special layout managers that like are a pain in the ass to actually use by hand. And so trying to do both sides was not worth the effort.
With code generation, there's generally I disconnected it. Oh well. There's generally two big schools of thought. One is three. One is you generate it once, and then from that point on, you're on your own. You edit it manually. A second is thou shalt not muss with generated code, and I am firmly in that camp. Third is we can have protected blocks inside the generated code. So you get generated code with little commented areas, and you can put code in there, and then the GUI builder or whatever's generating the code will remember what blocks are there, and when it regenerates the code, take your block and put it back in line. That said, I'm a firm believer in don't modify generated code. What that means is that your GUI builder or your code generator needs to provide hooks for you. So those hooks can take effect. Let me go ahead and see if I can get this up and running again here real quick.
Sorry, that's a rabbit hole question.
Oh, no. This is stuff I'm going to get into in more detail later, too. It was a comment. Mm-hmm.
Okay, good. And together that was the implementation of something like that.
I think they use that with like XAML when you're doing Windows forms, they can generate partial classes for you, which is super fun when you're trying to figure out where the actual class is.
Yeah.
Where is it generated? Oh, it's here and here.
Your declaration is something intermediate code.
Yes.
I almost got this.
Not XAML. XAML is a really nice.
XAML.
Sorry, XAML is really nice when it comes to making GUIs.
Do you pronounce all like things like that as one word? Is that your general policy?
As much as I can. Especially if it sounds funny.
Because I don't think I'm consistent at all. Because I was thinking that I've only seen that. I've never actually like used it. And I thought of XAML in my head when I looked at it, but
Uh-huh.
I've never used it, so I have no idea what like the people who work with that call it. You know,
I don't know why I said XAML.
I don't know. I just assumed you knew what you were talking about. So
Well, I mean, it's part of it is sometimes we automatically will say something as a more explanative way of saying it if we're not sure if everybody's on the same page. And sometimes it's just a reflex. That may be what happened there. So in the generated code, one of there's a couple different ways you can provide hooks to it. So you can have it generate some interfaces that you can generate the actual body code for it and then plug those in. This is a strategy pattern. So the generated code basically says, here's what you can implement. Go ahead and implement it and feed it to me. We've seen that with the parser listeners, right? It generated that interface for us. We filled in the details and fed it back in. There's also another way that this works in that you're going to create a subclass of the generated code. The generated code is your superclass. This is what's known as the generation gap pattern. And it's very, very commonly used for code generation, especially when you have annotations being used. So if you're generating code from an annotation processor like we were seeing before, it's very common to have the annotation processor generate a superclass for the annotated class. What that does is it gives you any number of methods that you can override in your subclass, or you can call the generated methods that are in the superclass. The drawback, some languages like Java, you're restricted to a single superclass. And that can be a really bad restriction for using this type of approach here. But it's a very common approach to solve that type of problem. Now, other types of code generators, like my favorite was Visual Age for Java. I wrote a book on this thing a long time ago. Great environment. It was before Eclipse. They had a fantastic GUI builder. One of the things that it would do is, like, whenever you had spots where you would need to have code, you could right-click on something and say, generate code for this, and it would give you a code editor. You edit your code, and it would remember that and then generate it into there for you. Anytime you wanted to edit, you edited the code in there. And the thing that was nice about this GUI builder is it was a Java Bean builder. It used all the Java Bean support behind the scenes. If you had a couple objects on the screen, like a text field, another text field, you could right-click on this and say when, and then you get to choose a list of events, like when the text changes, and then draw your line over to your target, and on that end, choose what you want to do. So you could say when this, set text, or when this, run a general block of code. And this made it really easy to do pretty much anything you wanted with the GUI and put in the code wherever you needed it, and you didn't have to worry about modifying generated code, you didn't have to worry about protected blocks, any of that mess. Superclasses, subclasses. It basically stitched your little blobs of code in with the generated code. And it had some great support for things like you could right click here and say the property on this guy synchronize with a property on this one. And it would actually automatically set up the appropriate listeners and synchronization code for things between there, which that was really common. And the place I use it the most often was that you could drop any old Java bean you wanted on the GUI builder. I mean, it didn't have to be visual. You drop it down there, and then you could say synchronize this property to that property in the Java bean. And that was fantastic, and very few GUI builders have that. That made it really easy to essentially set up a view model that you can just wire up to things and then do your real logic in the view model and not have to worry about any of the generated code. So if the code generation is done well, if somebody creating their builder does a really smart job on it, it can save you a ton of time. And you're not tempted to go and edit the XML or edit the code by hand. If it's done poorly, sometimes it's easier just to go to the raw source, which, as much as I hate doing that, now, there's a little evil part of me that wants you guys to write a GUI builder. But that's an evil part of me that I won't make you guys do, because I started to write a GUI builder for Eclipse a long time ago. I was calling it Penumbra, which I thought was a really cool, in the part of the shadow of the Eclipse. I was using the graphical editor framework in it to do it, and I was getting fairly far along with it, but then there were a couple other companies that were big companies and had multiple people working on such a thing, and they beat me to market. But if you come up with the right concept, that's really what sells it, and especially this type of thing here, where you can really just connect your code. That makes all the difference. So if we were writing a graphical designer for the state machine, we could do something like, if you wanted to have a before I execute a transition and after execute, we could have something kind of like that set up, where you could either right click and it pops up a little code editor for what to do before, or just wire it. And then that way that it gives you a really nice visual representation. Make sense? And the other thing that I wanted to do when I was playing around with that GUI editor is I wanted to have it automatically pick images to display different states of the objects. I couldn't figure out how to do it in that framework. But it looks like it's possible. I just have to find out the code for it. So I just wanted to kind of touch on some graphical representations here. We're going to talk about some others along the way and some other language workbench issues. But it's a good point that, depending on how things are implemented, sometimes it's just a waste of time. I mean,
It could also just been that this was a long time ago and I didn't know what I was doing.
well, I mean, some of it is the tool's bad. Some of it is the people just don't know all the wrinkles in the tool. And it's like when you mentioned word art. It's my daughter is taking she's going to college right now, and she was asking, hey, how do I do this type of a diagram? And I said, well, you could do this, or you could just try word art. She's like, what's word art? And I pointed it to her, and she's like, oh my god! And it's like, because it created a nice little hierarchy chart for her, which is all she needed. And it's when you don't know about a feature, you may think, oh, this tool's a pain in the ass to do things, but sometimes you can do some really cool things with it. So let's see. I wanted to come on. Oh, there we go. That's what I wanted. I'm on the wrong machine. There we go. It wasn't letting me do that for some reason. Do I have this in here? How do you like these diagrams? Aren't those pretty? um, There, this is the type of thing I was talking about, where you define your GUI in the GUI builder, and then you can wire it up. And this looks so clunky compared to what we have nowadays. This was actually based on an old tool called Visual Age for Smalltalk, and then they shoehorned Java into it. And I thought it worked fantastically, but Eclipse I think is much, much better. I just wish that they had this type of support in a GUI builder, because I think that's the way to do things. And you see the brackets around this? That makes it a variable. So this GUI that's generated, you can actually plug in that variable. And then, do I have an example in here? Yeah, then you can do something like this. Drop in the sub GUI, put in your variables for the pieces, and wire those models up. So he's the model for that guy. He's the model for the buttons here. And then this guy is saying when the button is pressed, go over here and change a value in the model. There's really cool stuff you could do in this environment, and it actually made me happy to use a GUI builder. Most of them are just, like the Android one. I'd rather edit the XML. And if you ever hear me say I'd rather edit XML, things are bad. I mean, XML is not pretty. So actually, that's what I'm going to have you do. I'm going to have you guys re-implement a GUI builder for Android that actually does things well. That'll be good. Okay, well, any questions on anything? Okay, yes?
When you're modifying that GUI, was it generating code behind the scenes?
In this here?
Code? No, in the Eclipse plugin.
Oh, this guy here?
Yeah. Or was it just only modifying the EM?
The
You're using
The-
the core to then generate code based off of that.
Yeah, it's actually generating objects. So there's actually this is generating the.
So what's the code behind it?
So I think we need to regenerate the code. Let's see. So from here, where was what? I'm losing myself here. I think it's this one here. That is not it. It's this one up here. Here it is. So here's the guy that has the state machine in it. And how do I generate the code from there? I thought there was a way to do that. No. There's a way to get it to generate the code in here. I just can't remember off the top of my head. I'll have to take a look at it. But it's just modified this DSL file. And it's like 3 million ways to view the same data. I'll have to take a look at it. There's a way to do it in there so that we can just have it generate the code. But I don't know if you can have it generated automatically or not. I'd have to look at that. There may be a way to do that. I haven't honestly. I haven't used EMF all that much. It's I've only used it. The only time I've used it is actually for X text because the models are EMF models. But then you can use those with any other plugins that accept EMF input. So like something like this. So, but I'll see if I can get to a point where I can figure out that and show you what the generated code looks like, because then that would be really nice. Just tweak this and boom, you have code. Okay. Any questions? Okay, and the assignment's due next week, right? Okay, if you have any questions on that, give me a yell. Otherwise, have a nice week.